As an active participant of 4 weeks International FTP on Environment and Sustainability, I, Mr. Ajim Sutar of D.Y. Patil College of Engineering and Technology, Kasba Boda, Kolhapur of Civil Engineering Department is going to present a topic on carbon footprint in wastewater treatment plant and greenhouse gases emission calculation. To go with the point, I would like to discuss my two videos in week number 1 and week number 2 dealing with sewage treatment plant process and general standards for discharge of environmental pollution. I thank you all for giving a great response and liking my videos. This is the wastewater treatment plant. It constitutes of preliminary treatment, primary treatment, secondary treatment and tertiary treatment. All the treatments are constituting the physical, chemical and biological removal of impurities. During the impurity removal, some amount of greenhouse gases are eliminated. Now week number 4 video will be consisting of the greenhouse gases emission calculation. After learning through video, students will investigate the greenhouse gases emission factors and the rate of emissions annually in kilowatt hour. Design a sustainable wastewater treatment plant with reduction in the emission of greenhouse gases. Develop a sustainable model to treat the wastewater with minimal greenhouse gases emissions directly or indirectly. Now let's see or move towards our final video, that is carbon footprints in wastewater treatment plant. What are greenhouse gases? Greenhouse gases can be gaseous compounds present in Earth's atmosphere which can capture infrared radiations resulting in the capture of heat and holding it, eventually causing an increase in temperature, causing global warming. This leads to increase in greenhouse effect. Greenhouse gases are carbon dioxide, methane and nitrous oxide majorly. Now what is carbon footprint? Carbon footprint is defined as the total set of greenhouse gas emissions caused by an activity or product expressed as carbon dioxide, that is CO2 equivalent, indexed in terms of global warming potential GWP, converting in terms of CO2 with a base value of 100 years, 1 for CO2, 21 for methane, 310 for nitrous oxide. Now let's move towards the next point, that is greenhouse gas emissions in wastewater treatment plant. Greenhouse gas emissions generated from municipal wastewater treatment plants in India is estimated in this study. The emissions from the wastewater treatment process as well as from the electricity used during the treatment process are estimated by using the methodology of Intergovernmental Panel on Climate Change, that is IPCC. The present treatment plants of capacity 15,997 million liters per day (MLD) contributes towards greenhouse gas emissions of 7.3 metric ton of CO2 equivalent per year. The future greenhouse gas emissions would depend upon the treatment technology used for treating 34,109 MLD of untreated wastewater. The highest greenhouse gas emissions would occur if all new wastewater treatment plants are based on upflow anaerobic sludge blanket technology, and lowest if sequential batch reactor technology is adopted. In the picture you can see an analogy or a pictorial representation or a flow chart constituting the municipal wastewater generation in India in metro class 1, class 2 cities. If treatment facilities available, the identification of sewage treatment technology UASB or ASP or WSP or OP is to be taken into consideration. Then if data is available like BOD, electricity use, etc. If it is available, then you can go for the estimation of CH4, that is methane, CO2 emission estimation using, etc. If no, then what you have to do? Then you have to assign weighted average emission factors obtained from the existing plans. If the treatment facility is not available, what do you have to do? Assume the treatment technology based upon scenarios. Different technologies assumed for different scenarios. Assign weightage average emission factors depending upon technology, and then estimate the the greenhouse gas emissions. Next, the greenhouse gas emissions in wastewater treatments are as follows. As I've discussed earlier, the wastewater treatment plant consists of preliminary treatment, primary treatment, secondary treatment, and tertiary treatment. All these units or the parts eliminate out the greenhouse gases as shown in the picture. The greenhouse gas emissions in wastewater treatment take place into these sectors. First is offsite greenhouse gas emissions due to energy consumption in wastewater treatment plant in kilowatt hour. Second is greenhouse gas emissions from anaerobic sludge treatment. Third is greenhouse gas emissions from activated sludge process. Fourth is greenhouse gas emissions from the degradation of the remaining constituents in the effluent. Fifth is the greenhouse gas emissions due to the use of chemicals in wastewater treatment plants. And last, greenhouse gas emissions from transportation and storage of the sludge. Now let's see one by one. Offsite greenhouse gas emissions due to the energy consumption in wastewater treatment plant. Electricity in wastewater treatment plant is needed to operate wastewater and sludge treatment processes. Coarse and fine screens, grit, tank bridges, primary and secondary settling tanks, blowers, pumps, motors, centrifuges, etc. for administrative building needs and for exterior illumination of plant. The CO2 emission were calculated according to the given equation, that is CO2 electricity is equal to C electricity into efficiency factor. In the graph below you can see the energy use. Next point is greenhouse gas emissions from anaerobic sludge treatment. Anaerobic is nothing but the use of anaerobic bacteria for the decomposition of the sludge. Greenhouse gas emissions from anaerobic treatments are calculated based on the Bridle mode using field data for biogas flow rate produced in digesters as well as wastewater treatment plants. The biogas consists of methane and carbon dioxide. Third point is greenhouse gas emissions from activated sludge process. These emissions are calculated according to Kakeur and Sternstrom 2005. The influent and effluent COD and BOD5 are considered as annual average values at the plant. Influent and effluent resulted from the measurement. The total greenhouse gas emissions is calculated according to the formula, that is CO2 ASP is equal to Y CO2 ASP multiplied by O ASP. Next, the greenhouse gas emissions from the degradation of the remaining constituents in the effluent. The soluble BOD remaining in the effluent generates CO2 emissions when organic matter is oxidized in the receiving water bodies. Considering a potential emission of 0.25 kg of CH4 per kg of COD discharged into the environment. The nitrogen that is not removed or is still remaining into the treatment plant is calculated as and has to be removed in the form of N2, that is nitrous oxide. Now next is the greenhouse gas emissions due to the use of chemicals in wastewater treatment plant. Wastewater treatment plant employs chemicals mainly for the treatment of sludge before and after anaerobic digestion. Values of emission factors for polymer use are between 1.182 kg CO2 equivalent per kg polymer up to 4.25 kg CO2 equivalent per kg of polymer used. And last, the greenhouse gas emissions from transportation and storage of the sludge. Refuses from screens and grid tanks are transported to the municipal landfill. The fuel consumed by the trucks is considered from the field data and using the methodology proposed by the different authors. The CO2 transportation is equal to fuel consumption multiplied by the factor, that is 2.6391, The unit is kg CO2 equivalent per day. Now, the greenhouse gas emissions reduction strategies. How we can reduce the greenhouse gases into the wastewater treatment plant. Now, the CH4 produced in the treatment process should be captured and used for the generation of electricity or used as a fuel at site. If it is not captured, it will discharge into the atmosphere and will cause increase in concentration of greenhouse gases in the atmosphere, which will lead to global warming. Indeed, the CO2 from the power generation can be eliminated if primary anaerobic processes are used. Overall, a largely anaerobic degradation of the wastewater pollutants seems economically and technically feasible and would have major environmental benefits in terms of greenhouse gases production. So, it's our duty to reduce the greenhouse gas emissions at an individual level, at a community level, and at a national level. So, we must make a habit of using the water in a very efficient manner and creating very minimal amount of sewage or wastewater in fact. So take into consideration and keep a keen thing into the mind that no dumping of sewage has to be taken place into the environment. Thank you.